Hey everyone, this video you're going to be looking over the moles gizmo. So by now you should be able to log in at explorelearning.com using your login. You went to the classroom and you found the moles gizmo, and this is what appears on your screen. When this happens, what I suggest is you go over here and you put the full screen mode on. This is going to make life a lot easier, especially if you have a small screen like on a phone. All right, this is what you see. So basically you've got a real life electronic balance and a super tiny electronic balance over here. We'll look at the first one. So let's look at sulfur, for example. So if I was able to take a single sulfur atom, remember they're extremely tiny, if I was to put it on this electronic balance, I have a mass. It has a mass of 32.065 U. Well, U must be super tiny because remember, this is the mass of a single atom. Atomic mass units. This is what you use on your periodic table, actually. And if you look at your colored periodic table, you'll notice that your mass is 32.07. It's rounded to 2 decimal places. So here we have a little bit of extra information. But nonetheless, this mass is incredibly tiny. How about going to the real life scale? Well, here I've got a container of sulfur powder. Let's add 1 times 10 to the 10 sulfur atoms. So 10 billion sulfur atoms. Let's see how much they weigh. Here we go. Let's add some of these. Oh, not much happened. Let's add a little bit more. What if I was to add, I don't know, let's go up to, maybe let's do a million. A million billion. So a million billion, 1 times 10 to the 15th sulfur atoms. That must be a lot. How much would they weigh? Oh, still don't have any sign of any mass being registered on stuff. So obviously, there are a lot of atoms in a gram. Let's keep adding. Let's go up to, I don't know, how about a billion billion? Okay, 1 times 10 to the 18th sulfur atoms. Add a small scoop. Still nothing. Wow, this is incredible. So we need a lot of atoms to make up even a bit of a gram. Let's add, I don't know, let's go up to 1 times 10 to the 20 sulfur atoms. So you keep adding, and you notice you have to go up to around maybe 10 to the 23 to actually register any mass. So I have to add 1.0101, or around 1 times 10 to the 22 atoms of sulfur for there even to be half a gram. So again, atoms have incredibly tiny mass. So to determine the mass of an atom would be very easy. You simply take the mass and you divide it by the number of atoms, and that gives you an incredibly tiny value. Okay, so now we're going to be looking at something called the mole. So the mole is special. So if I go here and you've got, let's go to sulfur again. I've got these little jars, and I can have a little slider over here. I can add things like atoms, moles, grams. I'm going to start with moles. So what's 1 mole? Well, if we add 1 mole of something, let's add 1 mole of sulfur. And there we go. The app has placed this into a jar. And what I can do with the jar is I can take exactly 1 mole and put it into an atom counter. And look what we have. 6.022 times 10 to the 23. What that means is this is 1 mole. That's how many atoms there are in a mole. So the idea is this mole is like a dozen or something like this. So you've got a dozen eggs, it's 12 here. 6.02 times 10 to the 23 is something. Hey, that's a mole. And then what we can do is I can empty it and it can maybe add another substance. Let's add, I don't know, how about aluminum? And do the same thing with aluminum. So when you have the aluminum, oops, sorry, put it into the counter, you get the same value. So a mole is always the same. Now there is something peculiar here. Let's look at iron chloride. So iron 2 chloride here, if I add 1 mole of it, I put it in here, we should have 6.02 times 10 to the 23. But look, what are we counting? We're not counting molecules. This is a problem with the app. We're actually counting formula units, so make sure you're aware of that. Okay, there's a big error in this app. So we're counting the number of formula units. So here we've got 6.02 times 10 to the 23 formula units of this iron chloride. Let's just go back a little bit and start with the sulfur again. So what I can do is once I have the mole of sulfur, remember 6.02 times 10 to the 23. Okay, I can put my jar over here, collect this. I can take the 1 mole and I can actually, oops, let me see if I can do it now. There we go. Pour it into the balance. And look what we have. The mass is 32.07 grams. But you're saying, wait a second. The mass of 1 single atom was 32.07 U. The mass of 1 mole is 32.07 grams. So that's the neat thing. once you know the atomic mass, it tells you how heavy 1 mole of that atom would be. So here, 1 mole of sulfur would be 32.07 grams. A really neat thing. So that's what you're going to be doing here. You're playing around with this particular tab here. Now, the last one you're looking at is this. And this is a series of questions you're going to go through. I think there's about 40 of them. There's quite a few. Okay. And you're going to click over here, show units, show numerical results. It does the math for you. So what we want to do here is how many grams are there in 3 moles of carbon? So we're going to use factor label or the factor cancellation method. So we've got 3 moles of carbon. So I have to change it into grams. So I have to go up here. I'm going to pick this appropriate tile. I'm not going to use this one because I have moles and atoms. I want moles and grams. Boom, there we go. And what I have here is I know that there's in 1 mole, there's exactly 12.011 grams of carbon. How do we know that? Remember, that's from the atomic mass. You just simply change the U to grams. The problem is I've got moles times moles over grams. Look at the unit I have here. I've got moles squared over grams. Something's not right. I want to cancel the moles, so we have to actually do this and flip the tile. And once I flip the tiles, look, the units automatically cancel, and you end up with 36 grams. And it kind of makes sense if you think about it. If you've got 3 moles of something, it's 3 times this value. So the actual answer is there. And that's what you do. You go through some of these and you check your answers and you get a sense of how to do this dimensional analysis or this factor cancellation technique that we do. So that's it. Hopefully that helps you out with the app a little bit. Take care.